Let's try to obtain equation of motion using calculus method. But before we go for that, we have to understand integration. The basic rule of integration for x raised to n is x raised to n plus 1 upon n plus 1 plus c. This is the equation for indefinite integral. Okay. Now, let's say we have integration 1 to 2 for t raised to 3 dot dt. Here, this dt will represent your variable. In this case, t is your variable. So that means we have to increase the power of t by 1. Here we have 3, so that will become t raised to 4 upon 4. And your limit is from 1 to 2. First equation is indefinite integral. Whenever we have limits, then we don't have to put the plus c sign. Now, let's substitute your upper limit instead of t. So we will get 2 raised to 4 minus substitute lower limit. So we'll get 1 raised to 4 divided by 4. So here we get 2 raised to 4 means 16 minus 1 by 4, or we can say 15 by 4 is your answer. Let's take another example. Let's say we have integration of 0 to d for v0 plus at dot dt. Here, first of all, your variable is t. That means we have to increase the power of t only. Okay. In first term, we don't have any t, or we can say we have t raised to 0. So if we increase the power, we will get t raised to 1. Right? Now in second term, we don't have to worry about a. We have t raised to 1. So if we increase the power, it will be t raised to 2 by 2. Limit is from 0 to d. Now, let's substitute your upper limit instead of t. So here we get v0d plus, in second term, a by 2 will be as it is. Replace your t by d, so we'll get d square minus, if we substitute lower limit which is 0, we will get v0 into 0 plus a by 2 into 0. So that will be 0. This is your answer. Now let's take one tricky question. Integration dv from v0 to v. First of all, let's understand what is your variable. It is v. Now we don't have any power of v, so we can consider v raised to 0. So if we increase the power, that will become v raised to 1. And your limit is from v0 to v. Let's substitute your upper limit, which is v, minus lower limit, so that will become v0. So this is your answer. Okay. So this way you can integrate. Now let's start your question. Let's consider an object constant acceleration, which is moving from x0 to x with velocity v0 to v in time 0 to t. So these are the limits of x, v and t. Okay, remember this thing. Now let's try to obtain your first equation of motion. We are going to use definition of acceleration. Acceleration a is actually dv by dt. If we move this dt on the left side, we will get a dt is equal to dv. So we are ready to integrate both the side. On left side, your variable is v, so we need its limit, which is v0 to v. And on right side, your variable is t, so we need its limit, which is 0 to t. Okay. Now we know how to integrate. Your variable is v, we don't have any term of v, so we can consider as v0. So if we increase one power of v, we will get v raised to 1. and your limit is from v0 to v. And on right hand side, we don't have to worry about this a because a is constant term. So a is outside, integration of dt will be t. Limit is from 0 to t. Okay. Now let's substitute upper limit. We will get v minus, from lower limit we'll get v0. Similarly on right hand side, from upper limit we will get t minus lower limit, which is 0. So here we get v equal to v0 plus at as your first equation of motion. Now let's go for the second equation, and for that we will use definition of velocity, which says that v is equal to dx by dt. If we move this dt on the left side, we will get v dot dt is equal to dx. Now on right hand side, your variable is t, and v is not a constant term. That means we have to convert your v in terms of t using equation number 1. We have v equal to v0 plus at. So substitute over here. We will get dx is equal to v0 plus at dot dt. Now we are ready for integration. On left hand side, your variable is x. So we have to use limit of x, which is from x0 to x. And on right side, variable is t. So let's use limit of t. So on left side, integration of dx will be x. Limit is from x0 to x. And on right side, your variable is t. In first term, v0 is constant. We don't have any term of t, so we can consider t raised to 0, and its integration is t raised to 1. Similarly, in second term, a is constant. We have t raised to 1, so its integration will be t raised to 2 by 2. Limit is from 0 to t. Now let's substitute upper limit. So we'll get x minus your lower limit is x0. Similarly, on left hand side, from upper limit we will get v0 t plus half a t square, and if we substitute lower limit we will get 0, so we don't have to worry about it. So we can say here we get your second equation of motion. Let's go for the last equation of motion. So again we will use definition of acceleration. A is equal to dv by dt. Now here we will apply chain rule. We can say we are multiply and divide by dx, but it is wrong. But still we will get dv by dx and dx by dt. Now we already know that your dx by dt is nothing but v. So here we get a is equal to v into dv by dx. Let's move your dx on the left hand side. So we will get a dx, and on right hand side we will get v dv. So we are ready to integrate both the side. On left hand side, your variable is v. So we have to take limit of v, which is v0 to v. Now on right hand side, your variable is x. So we have to take its limit, which is x0 to x. On left hand side, we have 1 power of v. So its integration will be v square by 2. Limit is from v0 to v. And on right hand side, acceleration is constant. We have to integrate with respect to x. So that will be x. Limit is from x0 to x. Now let's substitute. Your upper limit will get v square, and from lower limit we will get v0 square. If we move this 2 on the right side, we will get 2a, and substitute the limit, we'll get x minus x0. So tada, here we get your last and third equation of motion.